Hello everyone, this is Atomic Force Microscope. On the left side you will see the actual head unit where the sample goes, and it's actually on a 60 power optical microscope. We'll get to that soon. On the right side is the actual controlling box that will operate the AFM. Alright, if we go down to the bottom here, we're using the optical microscope because it's really hard to cantilever. You can see a little teeny little piece sticking up in the middle there, and the little red dot, that actually is a laser hitting the cantilever very end of the tip. On the left side then is an actual collector that'll collect it, a photodiode. On the controller unit of this device, we've got a magnification on the far left, just how much we want to zoom in. And down here is where we actually set the force, whereas the STM used tunneling current. This one uses repulsive forces as it scrapes across the sample. And then we've got over here the feedback, similar to the STM, that we can control how fast it goes up or down, away from the sample or towards the sample. This shows the general AFM. Here's the laser. It hits a mirror in this case, goes down to the sample. This is the cantilever right here. That's what holds the cantilever. As it hits that, it's going to deflect upwards towards, in this case, our detector, which is the photodiode. And the PZTs, similar to the STM, will raise or lower, in this case, the sample as needed to keep the right force from the tip to the actual sample. This drawing here shows the probe holder, and over on the right over here, that's the probe holder. There's actually what holds the actual cantilever, and there's the actual cantilever itself. That shows you the actual probe holder. It's pretty small, but huge compared to the cantilever. Now over here, get the light to reflect off it. These are the actual holders that actually have the cantilever on there. They're very, very small, but the cantilevers you really can't even see on there. They're so thin. And here, it shows the actual probe holder with the cantilever that you can barely see, but it is red because the laser is actually bouncing off there right now. And then there's our detector up there where it's the round part. All right, now here is my huge version of an AFM. We have over here, here's our laser, and on the unit, the laser is at a fixed position. That's important there because the cantilevers do break, because the cantilever in this case, they're like 10 times thinner than a hair. They're very, very, very thin. And at the very end, there's a tip. And the tip is the expensive part. I mean, if you want to do atomic resolution, you have to have something that's atomically sized tip, which means the tip has to be very, very small. In the case here, we couldn't do atomic with our AFM. Anyway, the cantilever is right here. The laser, it's going to bounce off it. And the first thing we need to do is actually line up the laser. You go ahead and turn the laser on. And actually then move the cantilever until the laser hits it at the tip. Oh, there we are. Now, once it does that, you'll see how it reflects and goes on to our detector. This is our photodiode detector. It can position, it knows where the light's hitting it as far as up or down, left and right. Now, if I have a sample, something like this, kind of looks like the monochromator gratings actually. At a fixed spot, then what we do, once we have it aligned here, now we have to move our detector around until at what would be considered an average height will be pretty close to the right at the middle of our target. And what happens when it scans? Well, if it gets to a really high area, you'll see that as this goes up, the deflection will also raise, and that way the detector will know that this must be a high feature on the topographic because it made this go up. And then as we go down to a lower level, it'll drop down. And if I go to a really low level, it'll go even lower. Now, because these are so thin, not only will it give us heights, but it also gives us each data point a direction of slope. So if I had something that was angled like this would end up pushing over here. That'll indicate it's got this kind of angle. And if it was angled like this guy would rotate a little bit over here and go over on this side. So we have both height, high height, middle height, low height, and a bend one way or another. Okay? So that's basically what it does. It simply scans, rasters across, gets all these data points, and then we put together the puzzle in the picture. All right, so since our cantilever is so amazingly small, it's really hard to get it lined up, the laser on it. So that's why we have the microscope. If I can put this over the microscope and get it in the right spot here, There we go. We can actually there see the little cantilever coming off the probe. Again, that big piece on the right, that was that little plastic piece I showed you earlier. And with the microscope, we can actually line up the laser so it actually deflects off it and goes towards our detector.